Assalamu alaikum students. Let's start with our lecture number 11 today on the application layer, chapter number 2. Today we are going to look into web and HTTP protocol on the application layer, particularly that how the HTTP protocol on the application layer is used between the web client and the web server. When a web client sends a request from the web browser to the web server, how that request is being processed and how the reply from the web server is sent back to the web client and a page is displayed in the web browser. I told you that some of the application layer protocols do need connection setup, and for setting up the connection they need the services of the TCP protocol, because we discussed in our last lectures that TCP is a connection oriented protocol, whereas UDP is a connectionless protocol. Okay, so HTTP protocol on the application layer, which is used for the communication between the web client and the web server, it does need the services of a connection oriented protocol on the transport layer, and on the transport layer the connection oriented protocol is TCP. It's been before the communication between the web client and the web server initiates, the TCP connection setup is required between the web client and the web server. Clear? That we are going to look into it today. That web page is basically, it consists of different objects. Okay, an object can be an HTML file or JPEG image or a Java applet video, small video animation, or it could be audio file or some static text written on the page. Okay, web page also consists of basic HTML file, base HTML file, and it could include several referenced objects as well. And each object on the web page is addressable. You can address it by a URL, Universal Resource Locator. URL means Universal Resource Locator. For example, here URL is given www.summerschool.edu, okay, /some department and picture.gif. Now this first part of the URL is called the host name. Host name means this is the computer or the domain name or the IP address on which this path depicts that where this particular GIF image is kept. It is kept on this computer in this folder, some department. In this particular folder, this picture is kept on this host, over this host, and definitely this host should have an IP address, and that will be a resolution of the URL into IP address. Who will resolve it? Who will do this conversion from URL or from domain name to an IP address? DNS server, domain name server. Domain name server is responsible for the conversion of the URL, the web address which you will type in the browser, or the website address which you will type in the browser. It will be converted into an IP address, because the devices, the routers on the internet, they do not understand the names, the URLs, the website names. They do need the IP addresses. So to give them the IP addresses, we have to convert the URL, the website name, into an IP address, and then that IP address will be sent on the internet. So who will do this conversion in your local area network? The DNS server. That's why we have a DNS server running in our local area network, which will be responsible for this conversion of the URL into the IP address. And then that IP, on that particular IP address, the request will be sent to bring that particular web page. Okay. So in our case here in HTTP, between the communication which is going to take place between the web client and the web server, it is an HTTP session, and for that a TCP connection needs to be established before this communication begins over the HTTP protocol on the application layer. Okay. So what will happen, the HTTP is called Hypertext Transfer Protocol on the application layer, which is used in between the web client and the web server. So it is basically web application layer protocol, and the model over here on which this protocol is going to be used is client server model. In client server model, definitely we will have a client computer and we will have a server computer. On client computer, the client application will be running, which will be a web browser, and on the server computer, the web server will be running, which will be web server. Here in our case it is Apache web server. Apache means it is Linux web server which is running here, and Linux web server is particularly called Apache web server. Okay. So on the client computer, when you run the web browser, definitely a web process for this web browser, a backend process will be running, which will be called a client process. And on the server computer, where the web server will be running, at the back end of this web server application, a server process will be running. So the process to process communication in between the client process on the client machine and the server process on the server machine, this communication will be taken care of by the transport layer, because the process to process communication is on the transport layer. So the web browser that requests any object will receive back that object, and it will display that web object in the browser, web browser, because on the client machine the web browser is running, and through the web browser the client machine is going to request an object, and that request is going to be sent to the web server, and the web server is going to send HTTP response. HTTP request is being sent by the client through the web browser. Here in this particular example, PC is running Internet Explorer web browser, and HTTP request is sent by the Internet Explorer to the web server, okay, Apache web server, okay, and the Apache web server will process this request, and it will send back the HTTP response to the client. Okay, client will receive that response, and client will display that web page or that particular object which has been received by the client from the server. It will display that web object in the web browser, in the window, clear, on the screen. And what is the job of the web server here in this scenario? The web server is basically sends objects back in response to the requests which are being sent by the web browsers, and the web server processes those requests which are sent by the web browsers, and accordingly the web server send back the response, and that response basically contains the objects, whatever object, whether it is an whether if it is a web page, that definitely that web page will contain some objects, and we have discussed at the beginning of this lecture that what those objects can be. It could be a Java servlet, audio file, or text, or some image, anything. Okay, so the client can be any client machine, whether it is a client running Windows operating system, Linux operating system, or Macintosh operating system. Can run different type of browsers: Internet Explorer, Firefox, Mozilla, Netscape, Navigator, Google Chrome, irrespective of the web browser. Okay, because they have to use the common protocol over the internet application layer protocol, which is HTTP protocol, hypertext transfer protocol. And the web servers and the browsers, they do understand this protocol. This is the beauty of the protocols, that even the different web browsers are talking the same language, which is HTTP, over the web. Clear, guys? Is there any question till here? Okay. Now the question is this, that HTTP is an application layer protocol. When it is going down on the transport layer, how the request will be sent from the client computer to the server computer. As we discussed that HTTP is a connection oriented protocol, it does need the connection setup first. Then the HTTP request will be sent from the client machine to the server machine. So for that particular case, it will use on the transport layer, it uses TCP protocol, transmission control protocol. So the client computer, client process is going to initiate first a TCP connection, and that TCP connection will create a socket, as we discussed the socket in our last lectures, and that socket is created to the server on port 80, because server process is listening on port 80. The web server on the server computer is listening on port 80. Its process, server process, is listening on port 80. What it is listening? It is listening the client requests. Okay, it is listening the client requests on port 80. Okay, so server will accept the TCP connection which is initiated from the client. Okay, and a connection will be set up between the client and the web server. Then the HTTP messages, application layer protocol messages, with the help of the HTTP protocol on the application layer, are being exchanged between the web browser, and in this case it will be called a HTTP client, because the client computer is using HTTP protocol in the web browser, and the request will be sent to the web server, and web server will be HTTP server process. So here it will be HTTP client process on the client machine, and on the server machine it will be HTTP server process. So on the transport layer, the communication will be between the HTTP client process and HTTP server process. After setting up the connection on the transport layer with the help of the TCP protocol. So before the HTTP data transfer begins between the HTTP client process and HTTP server process, a TCP connection will be established between the web client and the web server. The web server will accept that socket on port 80, because port 80 is HTTP port for the web server, and it is a well-defined port as we have discussed, and it is in between 0 to 1024. I told you almost all the well-defined services are between 0 and 1024, and 80 is in between this. Similarly, other services we have discussed already. Clear? So TCP connection is established, and the HTTP request and response messages are being exchanged, and the web page will be displayed on the web client browser, and after the page is displayed, the TCP connection will be closed. So HTTP is stateless protocol. Stateless means server maintains no information about the past client requests. It will not maintain any past client request information. If it try to maintain these state informations, it will be quite huge data, because millions of clients are requesting the website from the web server. It will become quite huge data. It will become quite huge data for the web server to maintain the record of the state of every connection, every HTTP request. That is why it is stateless, so that it should be a lightweight communication. Otherwise it will be a huge data, and to give a quick response to the client request will become difficult if there is a lot of data and it has to take care of the data, huge data. It will be difficult. That is why it is a stateless protocol. So protocols that maintain states are complex. The reason is past history. To maintain the past history or the state of the process data must be maintained, and we should keep a record on the server. If the server or the client crashes, their view of a state may be inconsistent at some stage, and it must be reconciled, otherwise the communication from the same point cannot begin. There are two types of HTTP connections. One is non-persistent HTTP and other is persistent HTTP. Non-persistent HTTP connection means that at most one object is going to be sent over a TCP connection. Once the TCP connection is established, our HTTP client request will come from the client to the web server, and the web server will send an object to the HTTP client. After sending that object, the connection will be disconnected. It will be off. So it is non-persistent. Persist means to exist. Let it exist. Non-persistent means after the communication of the object is being carried out, the connection will no more be there. It will be disconnected, because we are saying that HTTP is a connection oriented protocol. So before it sends an HTTP request, it will establish a TCP connection. First a TCP connection will be established, and then the HTTP request will be sent from the web client to the web server, and the web server will send a reply back to the web client, and immediately it will close the TCP connection. In comparison of it, we have persistent TCP connection as well. Persistent HTTP says that multiple objects can be sent over a single TCP connection between the client and the server. It means once the TCP connection is established, if the HTTP is following a persistent communication, in that persistent HTTP on one TCP connection, multiple requests and objects can be sent between that connection setup. It will not be disconnected after sending one object. There are two ways in which HTTP implementation is. Yeah. It depends that on that page how many objects are there. Okay. If there is only one object, it will be sent on that page, and the connection will be disconnected. Okay. Look here, non-persistent, how we will look into detail that how non-persistent HTTP will work. Suppose user enters a URL www.someSchool.edu/somedepartment/home.index. This is the complete URL, Universal Resource Locator, of this web site, and it contains text, references to 10 JPEG images. Now every JPEG image is one object. Okay, so on this page there is some text written, and there are 10 JPEG images on this web page. Clear? Now let's see how when the communication begins, how it will start transferring the objects. In the first phase, 1A, HTTP client initiates a TCP connection. First of all, the client has to establish a TCP connection with the web server. So HTTP client initiates TCP connection to the HTTP server process at port 80. Okay, so this is the host. This means www.someSchool.edu on port 80 means, for example, the web address of this host is 202.169.79.10 concatenated with the port number 80. Clear? So on the server, it will be the server IP and it will be the destination port. Destination IP and the destination port. Clear? Now HTTP server at host, for this host, this is the URL. For this URL, this is the IP address. Okay, you know that socket is a combination of IP address concatenated with the port number. So host means this is the IP address, because host name can't go over the internet. Who will resolve it into IP address? DNS server. Where DNS server is located? In our local area network. Very good. It should be located in our local area network. Before the request leaves our network and it goes over the internet, it has to be resolved from URL to IP address. Then that IP address will be given to the router, because the router should know where is the destination, where is this IP address, because router has to check that destination IP address into its routing table. So the request, when we will write the URL www.someschool.edu in our web browser, and we will press enter, the request will go to the DNS server on the LAN. Okay, the DNS server will look into its database and look for this URL and get its IP address, and that IP address will be given to the router, our gateway router. Our gateway router will look into its routing table, that can it send the packet to this particular network. Okay, this is not the IP of the network, this is the IP of the destination host, that web server. But the first part of this, there are two parts in the IP address we will look into detail. One is the network part, other is the host part. So it will compare the network part in its routing table. If the network part is there, it means the router can route the packet to that particular network. Once the packet has reached to that particular network, it's only the question that how that packet will be delivered to that particular host, because the host is already available on that network. Clear? This complete story, IP addressing, we will look into detail of it. Okay, clear? So the packet, the router will look into this destination IP address. If it can route a packet to this destination IP address, if this network address is there in its routing table, it will start routing the traffic over to that network. Okay, so HTTP server at this particular host is waiting, the process which is running on the HTTP server, it is waiting for the TCP connection at port 80. Once a request to initiate a TCP connection from the client comes to the server at port 80, a connection is established. This request is accepted and a connection is accepted, and it is notified to the client that okay, I have accepted your request and I am going to initiate a connection. So it will be acknowledged by the server that a connection is set up. So HTTP client then starts sending the HTTP request message, and that request definitely contains the URL. But this URL first will go to the DNS server, it will be resolved into an IP address, and then on that particular IP address, our router will send the traffic, the request. Clear? So the HTTP client will send HTTP request message containing the URL into the TCP connection. URL means this is the IP address containing the TCP connection socket, and the message indicates that client wants object some department / home.index on that particular URL. So look here, this part is basically indicating the object in this particular folder on this particular host whose URL is given, and this URL has already been resolved into an IP address. Clear? and now this request will go through different routes by going through different routers, because this could not be a direct connection between the web client and a web server. There might be so many hops in between, and those hops are called the routers, whose job is to route the packets to the destination. So after going through so many routers, intermediary hops, the request will reach to the web server ultimately. Clear? The HTTP server receives the request message, okay, and it will form a response message, and that response message will contain the requested objects, and in our particular case it is home.index page, and sends message into its socket, because socket is a way of communication between the client and the server. Clear? So the response message will be sent back to the client from the server. So the time is going in this direction. Okay. After sending the response to the client, the HTTP server will closes the TCP connection. Why? Because it was non-persistent TCP HTTP connection. After that, HTTP client receives, once it receives the response message containing the HTML file containing that particular web page, it will display that HTML file into the web browser, the complete file. It will be considered one object. It will be displayed into the web browser. Parsing HTML file, and it finds 10 reference to JPEG objects. Now that text file is one object, but on that text file there are how many objects? 10 objects. And for those 10 objects, from step 1 to step 5, from here till here, step 1 to 5 will be repeated for each of the 10 JPEG objects. Now this is the sign. The file, text file, in the beginning I mentioned here, it contains text, page, references, and the references to 10 JPEG images. So one object is the HTML file. On that page there are how many objects? 10 JPEG images. And each image should be considered as an object, one object. So there are how many? 11 total objects. So one object, the first object, will come as a web page, and the non-persistent TCP HTTP connection will be finished. Okay, TCP connection will be cut off, and for every object from step 1 to 5 will be repeated 10 times more to display the 10 images. Clear? Non-persistent HTTP response time. Now, how much time it will take to bring that one text file with 10 objects? How much total time it will take? Okay. This is very interesting, and please be attentive here. Now this is very important here, boys, that how much time it will be taken to get back the response from the web server when in the non-persistent HTTP the client has requested some objects from the web server. So how much time it will take? This is very important point. Definition of the round trip time is, we will use round trip time in this case. And round trip time is the time for a small packet to travel from client to server and back to the client. For example, if this is a client and it is going to send a request, for example, consider it initiation of a TCP connection request. So the request will be sent to the server from the client, and a reply will come back from the server to the client. So this much time will be spent in sending a request from the client to the server in order to initiate a TCP connection, and the server will send back a reply to the client that okay, your request has been granted and your connection is setup is matured. So this is one round trip time. Round trip time means starting from here, go there and come back here. This is called round trip time. Okay.
Do nothing. Round trip time. Do nothing.
Yeah, definitely. In this round trip time, yet the HTTP request is not being sent. Yet we have not sent the HTTP request. And this round trip time will be a time in which the connection will be established. Okay. Now, from here, the request, it will request the file, the HTML file. The client will send another request, okay, to retrieve the HTML file, to get the HTML file. First RTT is to set up a TCP connection, and second RTT is to request the file, to request the object. Okay. Now the client is going to send a request to get the file. Now how much time it will take to send back the object from the server to the client? It depends on the size of the file. Look here, time to transmit the file is this much, thickness of the file, that how huge is the file. The request has been received on the server. Send this HTML file to the client. But now the client has to wait unless until the whole file from the server is downloaded on the client. A web page, complete web page is received on the client from the server, and the web page is displayed on the monitor. So it depends on the size of the file. How big is the file? The more bigger the file, the more time it will take. The smaller is the file, the less time it will take. So the second request will be affected by the size of the file. Okay, so it will be 1 plus 2 round trip time plus the size of the file. Okay, so the file, once it is received, it is started from here and it will be received here. So response time is equivalent to 1 RTT round trip time to initiate the TCP connection, and 1 RTT for the HTTP request, and first few bytes of the HTTP response to return, plus the file transmission time. So the total time, response time, will be equivalent to 2 RTT round trip times plus the transmit time to transfer the file from the web server to the web client. Yes.
Can round trip time can be more than 2?
More than 2 in yeah, it will be more than 2 in case, no, in one object case it will be 2 RTT plus the transmission time for the first object. Okay, then for the next object it again depend on the object size. This is basically the object size. Here in this case it is 2 RTT plus transmit time for the one object. Okay, for every object it will be like this. If it is non-persistent, okay, this is non-persistent HTTP response time. Yes, another question.
So, Doctor, I request a website, and the first TCP connection will be done, and the request file will be done.
Yeah.
Then if I go to another page in same website,
Yeah.
so there will be another TCP connection.
Yeah, exactly. In case of non-persistent, it has to establish another TCP connection again, and then it will again one TCP connection RTT for setting up the TCP connection, another RTT plus the to send the request and receive the object, including the object size time. How much time it will take? It depends on the size of the object. Clear? Non-persistent, HTTP issues versus the persistent HTTP issues. Okay, it requires 2 RTT per object. Per object, I told you, per object, for every object 2 RTT. OS overhead for each TCP connection. Now it is little bit overhead. Why? Because for each object OS has to bear the overhead of establishing for every object a TCP connection. It needs a separate TCP connection for every object. So it is an overhead for the operating system that it has to create a TCP connection for every object transfer. So browsers often open parallel TCP connections to fetch reference objects. Now here what it will do, how they will handle it, how they will control this burden, that the browser often they open the parallel TCP connections because multi-threaded applications are there, and every thread will open a multiple connection to, because see, it is not like this that if 10 objects are there you will wait for every object to let it come and then it will be displayed. These are multi-threaded browsers, and in multi-threaded browsers in one process multiple thread can run and multiple thread can fetch multiple objects, and at the same time on the page multiple objects will be displayed. Clear? Whereas in persistent HTTP, server leaves the connection open after sending the response, and further objects can also be transferred from the web server to the client. Subsequent HTTP messages between the same client and server are sent over the open connection again. Okay. Client sends the request as soon as it encounters the referenced object is received, as little as 1 RTTP for the referenced object. 1 RTTP for every object is approximately enough.
At least.
Yeah, at least for every object. Now you look here, HTTP request message format. 2 types of HTTP messages are there, request and response. Request is sent from client to the server and response is sent from server to the client. HTTP request message format, look here what is there in the ASCII human readable format in that message, get. We will look into this in our labs when we will use the Wireshark to get these messages over the Ethernet. Okay, because the Wireshark will sniff these segments from the LAN and you can look into these. The structure will be like this: get some directory /page.html. This is the directory in which this object is kept. We are requesting, this is a request line to get this particular object kept in this folder, okay, on this host, and for this host definitely we will have its IP address, and the protocol used between the web client and the web server is HTTP version 1.1. okay, so this is the request line, get, okay, user agent, whatever agent user you are using, it is Mozilla 4.0 web browser. User agent is your web browser, and connection close mean after this object is received the collection will be closed. It means it is HTTP non-persistent HTTP, and accept language is French. Okay, so get, post, head, put, delete command. This is the command to complete header lines, okay, to get this object. And carriage return is here, enter, and carriage return or line feed indicate end of the message, and extra carriage return line feed can be given. Okay, so this is one get request to get this particular object on this host kept in this folder using HTTP protocol version 1.1 through the web client browser Mozilla 4.0, and close indicates this is non-persistent HTTP and the language is accepted language is French. Okay, now the next thing is the post. Okay, post mean web page often uploading from the input. Web page often include form input. Input is uploaded to the server in the entity body complete. For example, like this, look here, www.somesite.com/animal research monkeys and banana. URL method, this is the post method, this is the URL method. There are 2 methods to uploading, okay, uploading from input. You are uploading the input. There are 2 methods to upload this input. or send this request from the client to the server. The URL method says that uses the get method, and get method is used to fetch the object, and input is uploaded in the URL field of the request line. Here web page often includes the form input. It has some form in which there are some fields in which you can input the data. Usually it is the scenario where the web page is linked or hooked up with the database to pass on some data into a file, text file at the back end on the web server. Have you seen on some pages you give your name, your email, and a small text box is there in which you can write some description and you submit it? So this is the post method. You're going to post something, post some message, okay, in those particular fields which are mentioned on the web page. Okay, so input is uploaded to the server in entity body, whatever input you want to send, and this is the URL method. HTTP 1.0 and HTTP 1.1 get post head and get post head. Okay, same. This is the difference between the comparison between the method types. Okay, ask servers to leave requested object out of the response. Server respond with HTTP message and leaves out the requested object. Okay, over there on the server. It is used for debugging by application developer, whereas 1.1 uploads file in the entity body to path specified in the URL field and delete the file specified in the URL field. Here it keeps a copy on the server, where here it uploads the file in the body to the path specified in the URL, and it deletes the file specified in the URL from the server once it is retrieved. Okay, we will stop here, and from here we will continue in our next lecture.